Hello, everyone. This is a live stream. Management of Operations, BUSN 6630, Section 1, Spring 2021. And this lecture is going to be on inventory. Now, there's going to be 2 lectures on inventory this week, and then next week will be a second lecture on inventory. So to get started here, let's bring up the syllabus. And in the syllabus, you see here, this week, the inventory is just going to be constant demand, kind of like the basis. The demand is constant. Everything is totally organized. Constant. Everything is defined. And then next week, on the 16th, that's when I will take the inventory a little bit deeper and talk about stochastic demand and more realistic, because demand is not really constant. It's really a random variable. And then allude to the lead time also as a random variable, stochastic. Stochastic means it's random. So so that's what I'll be doing this week and next week. And I have made some changes in the. Let me pull up the chat. Okay, I have. All of this is all new, and so I'm making changes again. Here's what I'm going to be doing, because I know last couple of weeks, when I do a live here, what happens is sometimes I make a mistake or go back, and it just gets longer and longer. So let me bring up Canvas. Here we go. Here's the home page, and let's go ahead and come down to inventory and the inventory. And so now it's going to be Inventory-1 this week, Inventory-2 next week. Video 1 is going to be today, and that's going to be posted. Next week it's going to be here. But notice how I'm doing this. These videos are just going to be on the lecture. Now, what I'm going to be doing here this week, next couple of days, and I've already posted the questions here, and then I'm going to post a video just on the quiz. And then down here, it'll be a video just on the homework, and then a video just on the memo. So I'm going to start having videos just on those assignments. And I'll do those separately, not necessarily live. I'll make the video and then post it so you can look at it and see if you have any questions. And that might, to me, I'm thinking for a student learning this, instead of going through it and trying to do it very quickly while I'm doing it, maybe you're going to look at it, put down your questions, and then ask me during office hours or next week during the live chat with the chat. So I think this might even be a better format. And if it is, then good. If not, then let me know. There may be a better way to do this, because all this is fairly new, and I'm trying to converge into something that's going to be simple, easy, direct, and also maximize learning. And to maximize your learning, you try to minimize how many things you have to look at. That's why I'm putting everything. Can everyone see the material for this module? Let me make sure this module. Let me see here. Let me pull this over here. Okay, thank you, Raphael. Let me make sure again. This is inventory. Let me change this. Oops. I think I just got out of it. Okay, now see if you can see it. I wasn't sure. Okay, now see if you can see. Yeah, it's locked. I thought it was unlocked, but there's a window. There's like 4 or 5 windows. One window had a date, and anyway, it's a lot. It's not that easy to navigate. Can you see it now? Can you go inventory And can you see the inventory now? Can you see this module? Got it. Thank you. Thank you, Raphael. Good. I've learned something. Now I've open, publish. And then I realize over here on this, anyway, there's like a 10th little thing I have to click. And I didn't know if I need to click it or not, but now I do. Now I know. Oh, good, Sridevi. Good. Wow. So homework 3. Yes, for homework 3, I say let's start down here. Is it the same for homework 3? The updated format is helpful. It's locked for me too. Okay, I can't see it. Okay, it's locked. Oh, for memo 2, I see that, okay, I see that you had incorrect values of profit calculated when you showed how to solve it in class. Okay, I will look at memo 2. Okay, I'll see. We'll communicate and see what you mean by that. Got it. Thanks. One-stop repository is working great for me as well. That's really good to know. It has. I might say. Okay, I got to be careful saying this stuff, but I don't care. I've been here long enough. This is not how they taught us to do it. Okay, and I say, I'm not going to do it the way they tell me. Each one of these is a module, and you have to hunt and find. And no, I'm going to put them all together, chronological. Here it is, and all of this, everything in inventory is going to be on this page right here. Okay. Anyway, okay, let's see here. Got it. Thanks. Got it. To access inventory now. Very good. I think that might have been intentional. If you could support your values, I don't think it mattered. For the Memo 2 video, I have sent you the Google Drive link. Good, good. Oh, brings up a very good point, Steve, a very good point. Many people, a few people, I couldn't open it, couldn't download it, open it. A few people didn't send the video, okay, the MP4. Now, the memos are different than the homework. There's no late assignments for the homework because I post the answers. But the memos are communication. Each one is different. Each one is unique. And it's unique because it's yours. And so you can submit these things later for full credit, okay? And if I've taken off like 1 or 2 points, submit it again. Just correct it. Because what I would like for these memos is to have something that is like a representation of this course, a takeaway. You probably won't be remembering the homework or even the lectures. The knowledge is there. But the memos are something you've done. And that's a takeaway that you can take from this course that's valuable. So just redo them and resubmit them, and that's perfectly fine. But make sure you identify you're in this course, and it's BUSN 6630, graduate operations, that type of thing. Because this only applies to this course, not other courses. Okay. Okay, for quiz 3, question 2 was very confusing. You tricked us. Okay, maybe. Quiz 3, question 2. Okay, that's okay. A few more minutes here. Quiz 3. Quiz 3. Question 2. Well, I wanted to emphasize. I wanted to emphasize that, and the logical answer on question 2 is, I said that the level capacity is defined by capacity. Chase demand is defined by capacity. Mixed is defined as not level, not chase, no negative inventory, blah, blah, blah. Nowhere in there was cost talked about. So cost could be anything. Actually, as a matter of fact, you can have examples. Oh, and also notice I said always produce the minimum. In other words, it's not always going to produce the minimum. Okay, anyway. Yeah, I don't think Memo 3 is live yet. Okay, notice, oh, Memo 3. Oh, yeah, I haven't, it's not live yet. I need to put it out there. But the reason I'm waiting is because, well, I just haven't got to it yet. But on Memo 3, number 3 here, because what I'm doing here is I'm going to have this, and there's an Excel template here, but then right after that there's going to be a video, and so essentially I'll be showing you Memo 3 on how to work it with this Excel template. Now this Excel template for Memo 3 is in my website, but I pulled it in here to make, because it applies to the memo. Okay, and so therefore Memo 3 coming up next week. So I will have a video there to show you how to do it, so you have a little over a week to actually write this stuff up. Kind of like I have been doing. I kind of like for these memos, what I like on the memos, we work together. I work it out just like I've done, and I say, hey, you know, this is what I found. You can add to it, work it a little bit, change it a little bit, but then you have to communicate it. And what you communicate, you have to defend. So I'll give you enough to put in a memo. And I noticed some people in this memo 2 here that I just created, I've noticed some people take mine and expand it, go deeper. Some people just take mine and just do that. And they don't go much further than that, which is, all of the above is fine. It's fine with me. You can go further or not go further, depending on how much time you have, how much interest you have. And everyone is not necessarily interested in everything. But in this course, it's a core course. Everyone should have a certain level of understanding and capability. Okay, and then above that, some people do more and less. That's how I see it. Okay, let's see here. I'm kind of stalling to see if there's more questions. The Memo 3 link is not live. I think the LP mix, optimal mix, is what the answer was, or none of the above. Oh, which brings up another point. Well, Craig, you didn't say this, but it reminds me. Another point, notice I'm going to start doing this. I'm going to have my office hours, and then in bold, we'll have the question and answer, and people are starting to use this. I'm glad to see that. Like share answers. Here's my spreadsheet. What do you think? Or here's what I did. Or what's wrong? What's the answer to this one? You know, and it's okay with me if everybody comes in with the same answer, as long as they're all right. But as long as everyone's learning it, don't just copy. Learn from each other. Okay. But anyway, I think that's how business works. If you want to be right, don't be an island. Get information from everyone. Okay. Anyway, so I'm going to have this Q&A every time. So post questions and answers here. And I'm going to come here first to see if there's any questions unanswered before I go to the email. Because my email from students is a lot, but it's probably twice as much from the university. And so sometimes I just don't get to them. Okay, that's enough complaining and enough. Okay, I think we're ready to go. Very good. Okay, inventory. So notice the progression here. Forecasting and linear program, those are tools. Aggregate planning is top down. Inventory and labor are key elements, or inventory is a huge asset within any organization, especially in production or manufacturing. But even inventory is important. Without inventory, it's hard for 80-90% of the businesses, even service industries, inventory is sometimes important. Now, MRP is an expansion where it takes the inventory and scheduling and goes to ERP and beyond, and multiple item inventory. And then scheduling is day-to-day operations. So I start with tools, top down, and then I have bottom-up scheduling. Now, the project management and quality management, these are specializations within operations. And project management is becoming popular in almost every organization, especially because of today. Things are fast, and quality management has pretty much every organization, simply because of back in the 70s, 80s, and 90s. We're from the 60s, and then 70s and 80s. Then all of a sudden, quality management became more of the mainstream. Okay, and so it's really part of every organization. But so we're ahead in quality management today. But project management is a couple of decades behind. But in a decade, things are going so fast that project management is going to be mainstream. And I think operations management in about 5-10 years from now, you'll start with project management to understand that, and then you go into operations. Okay, because I've seen a lot of trends over my years, in my tenure in the industry, and then in academia. Okay, so let's do inventory. Click inventory. Okay, what I'll be covering today is just Inventory-1, going through the definitions, a little bit on the calculations, computations, and then down to here. And the video here that I'm doing right now will be right here and posted. Okay, I think that's enough for an introduction. Let's get to it. Okay, let's bring up the lecture. And here we go. Okay. Craig, you're absolutely right. And if project management is I think should be a core course, some business schools start with project management for all the disciplines, for finance, accounting, management, everything, marketing. And then Gantt charts are just so common. Now, I teach a project management course. I'm teaching it now. I take Gantt charts. I go into PERT. I go into all different types of things because I used to consult in project management years ago, and with large corporations, and small, medium, large project management. Just the knowledge of it is key. Okay, here we go. Inventory control, inventory management. Okay, first of all, here's the input-output model that I start with on every one of these disciplines, areas, topics. First of all, inventory. You can acquire items from the supplier, and that will increase your inventory. You can distribute items to the customer, and that'll decrease your inventory. So whether you acquire items or distribute items, your inventory goes up and down. And so the whole idea is managing this inventory. And managing this inventory of up and down, and it costs money to hold it, costs money to order it, and the distribution of it is important. So we'll have lead time upstream, we'll have demand downstream, and the management of this inventory is key in 80 to 90% of companies. And also notice in aggregate planning, inventory is a key element of aggregate planning. Okay, so from aggregate planning, we're coming down to inventory. Understanding inventory is very important. Okay, before we get into the details, let's start big picture. There are different types of inventory. 3 primary types is raw material, WIP, work in process, and finished goods inventory. The idea of raw material, WIP, and FGI is that let's suppose we're making tables and chairs. That's our manufacturing process. Well, we're going to buy wood from the lumber yard, and so when that wood comes into our yard, that's raw material. It's just raw material. They're not tables and chairs yet. Once we've made tables and chairs, that's our final product. That's going to be our finished goods inventory, our finished goods final product. But in the process of making the finished goods, we're going to have partially made tables, partially made chairs. We're going to have wood. And so all of this is called work in process, and that's inventory. So WIP is an inventory. It's work in process. So when your production process is very inefficient, you will have a large amount of WIP inventory. And there have been cases where WIP inventory is larger than the raw material and finished goods inventory because their production process is so inefficient. Not only in manufacturing, but also in services, because you don't have trust, you don't have timeliness. And so to reduce WIP, and there's where you go into JIT manufacturing or make to order so that you have inventory just when you need it. Okay, well, make to order is inventory strategies. You're backing up JIT as your production strategy that matches with make to order. Okay, other types of primary inventory are component inventory. You have different components within your finished goods. Distribution inventory, when it's distributed to your customers. And sometimes the distribution lead time is not just hours, it could be days, months, weeks, or months. So therefore that inventory, which is in transit, where is it, who owns it, who's paying for it, and so the distribution inventory can be important. And then there's two types of important inventories: MRO, maintenance, repair, and operations, or M&S, material and supplies. Now the idea of MRO, maintenance, repair, and operations, is that this can be equipment, it could be capital expenditures, but things that are needed to run the operations on a weekly, monthly, quarterly, yearly basis. Usually these are larger ticket items. They go through procurement. But M&S, material and supplies, these are consumable items. These are items that are used up, okay, like pencil and paper and paper clips and a toner for the copy machine. As a matter of fact, the copy machine could be MRO, but the toner is M&S, material and supplies. And so these are like usually low ticket items, low price point, and usually the material and supplies are called type. Down here we're going to be talking about A, B, and C items. Okay, the C items are staple items. Okay, a lot of times material and supplies are low ticket items, cheap. Staple, there's where staple comes in, the store staple. Low ticket items, so you buy in bulk to drive down the price because it's price sensitive. MRO, sometimes you can have contracts. They could be equipment, could be lighting, could be copy machines, and that type of thing. Those are primary types of inventory. Secondary types of inventory are spare parts inventory in some industries, warranty inventory, if you're given a warranty, your product, returns with reverse supply chains, research and development. In other words, inventory that's within your R&D, research and development. You're not making money on it immediately, but you have value from that inventory because of R&D, research and development. And then quality control. And this quality control is like in the quality control department, they're doing testing, this type of thing, to see what's being damaged and everything. And then promotional items, where you're giving away things for marketing. So these are secondary type inventories. Now, interestingly enough, you have these primary then secondary inventories. You think, okay, well, spare parts, let's say. Let's see here. An inventory that's not here. Interesting. This is not all of them. There are others. Another one that's not here is, let me just put this in here, scrap inventory. By warranty, do you mean actual warranty or inventory under warranty, replaced under warranty, or waiting warranty work? It is going to be, this could be, the warranty inventory would be, what I'm thinking of here is if it's under warranty and it's going to be replaced. So you have inventory that's going to be replacing that. And it's because some of the warranty is from the actual retail store, and some of the warranty is from the manufacturer. So the manufacturer has a warranty, then they're going to bring it back and then rework it. If the retail store has a warranty, will honor the manufacturer's warranty or their own warranty, they're going to accept it and give it and replace it and then send it to the manufacturer. So however you do it, there's going to be inventory involved. Okay, scrap inventory. You know it's not in here. I'm not going to put it in here. I mean, I'm not going to put it permanently. The reason I put that in here, and I got to be careful not telling stories. I got 1 million stories, and we could stay here all night just me telling stories. Actually, that's a good question. Is JIT considered a type of inventory like WIP? No, it is a production strategy, production theory, production approach processes. It's your production, just in time, like Kanban systems. WIP is the inventory within a JIT system. It's kind of like you have your operations, and then you have your inventory in your operations. The operation strategy is JIT, just-in-time production. The WIP is going to be the inventory within that. So they go together, but they're two different things. Okay, scrap inventory. Let's see here. Years ago, I had a friend. He worked for a large corporation here, and we got to be friends. We started chit-chatting, and I said, what do you do? He said, I'm an inventory manager. I said, oh, you are? With what company? A large company here. And I said, oh, okay. Really? You manage scrap? He said, oh, yeah. As a matter of fact, the scrap inventory is pretty big because, they fabricate things and make things. And he says, actually, different parts of the year, our scrap inventory in dollar amounts, because it's a secondary market, is larger than any inventory we have. It's larger than raw material, WIP, or finished goods inventory. Our scrap inventory is larger because they use metals and different kind of metals, sometimes precious metals. So they have all different scrap. It's not one thing; it's a lot of things, aluminum and copper and things. And sometimes our scrap inventory has a larger, say, market cap in certain types of the year than other inventories, than even our finished goods inventory, different times of the year. I go, I never wouldn't think that. Yeah, most people don't. Anyway, he's managing it, and so he brings up a lot of money for the. Okay, let's stop telling stories and move on. Okay, purpose of the inventory. Why do you have inventory? First of all, we're going to have routine policy and then transient policies that come and go. First routine policy is to satisfy demand. And that's called the lot size, order quantity, cycle stock, all mean the same thing. Okay, and basically here it says, I'm going to order my lot size, my order quantity, I'm going to order that from the supplier in order to satisfy my demand downstream. Okay, and that's what that is. Okay, then the next is a routine policy to protect against stock out. Now we've defined stock out. We introduced stock out in aggregate planning. Remember, stock out is when you have demand on a system, but you don't have inventory to meet that demand, and so you have unmet demand. That's stock out. That's lost sales, lost revenue, sometimes lost customers. But so to guard against that, you have inventory to guard against it by carrying extra inventory, and that's called safety stock, buffer stock, or reserve stock to satisfy your demand. Your demand, which is greater than you thought. You predicted demand, and all of a sudden it's more than you thought. So therefore, you're going to have inventory to satisfy that, to lower the probability of stock out. And then you have transportation or pipeline inventory, and that's a routine policy to satisfy logistical requirements. And so again, sometimes like for commodities, I teach a commodities course. In commodities, you have some of them are very long lead times. Lead times are a time between when you place an order from the supplier and receive the order. Like I might place it on January 1st, and I'm going to get it on January 5th. Well, the lead time is 5 days. If I place it on January 1st, I get it February 1st, the lead time is 1 month. And sometimes in commodities, for example, I place an order on January 1st. I may not get it till June 1st. Okay, so it's like 5 months of lead time. So when that's true, then your transportation or pipeline inventory, depending on the product, is a routine policy to satisfy your logistical requirements because it takes that long to get them. Okay, and then we have transient policies, two categories. One is anticipation or seasonal inventory to respond to known or forecasted demand. I want to emphasize known or forecasted. So it's something that you're expecting. It's something that you have forecasted. For example, seasonal inventory would be forecasted demand. Anticipation is that you know something is going to happen. You're not really you don't know exactly how much, but you're anticipating something happening. You see it coming. Wow, Craig, this is a really great. I work in roof restoration. Stock out with our suppliers is a concern from COVID production disruptions. Yeah, this year, actually 2020, 2021, stock out and the supply chain and transportation and inventory, even with our pharmaceuticals, with the different Moderna and Pfizer and now Johnson & Johnson, all that has come to the front. It's kind of like operations and inventory is kind of like boring when it all works. But when it doesn't work and it becomes critical, all of a sudden it becomes really interesting. How can we make this work, like in the case of vaccinations, to save lives, or to prolong lives, or to reduce the incidences of death? So it's a fascinating area. When you get into it, it's pretty darn interesting. Okay, well, anticipation, you anticipate something happening. Let's say, a good example of that is that we're going to have a new vaccine come out. Well, you anticipate a supply chain. You're going to have to create some type of logistical capabilities in order to get it from the source to the destination. The other is speculative or hedge inventories. These are transient policies to respond to unexpected demand for critical inventory. Again, critical inventory, a good example of that is the health industry. You can speculate you might need something, or you can hedge inventory to hedge against running out of critical inventory. Because if you run out, all of a sudden the consequence would be death. And so you're going to hedge against that to almost minimize that probability to almost zero. Now, speculative is different. Speculative says, well, I'm going to speculate. I might need just about this much to try to minimize my probability of stock out. Well, we'll look at this speculative inventory next week when we have a probabilistic or a stochastic demand, and we'll actually calculate it. And I'll show you how to do it a number of ways. Okay, moving on, metrics. First of all, you can metric. How are you going to measure this inventory? Well, you have the performance here in aggregate, and we will be looking at the turnover rate here soon. Turnover rate, demand rate over inventory carried. The other is called the inverse of that is the supply, inventory supply. We won't get into this here. It's not used nearly as much as turnover rate, but it is a metric that has been used before. But we'll focus on the turnover rates. Now, this effectiveness, I just put a bunch of stuff in here. The measure for effectiveness of inventory, really, there's, how many do I have here? If I have 6, 8, 10, there's going to be dozens, if not hundreds of these spread all over. Every company will have its own measure. And so the measure that you would have as effectiveness depends on the strategy, the aggregate strategy, depends on the philosophy, depends on the company, the culture of the company, etc. But here are some of them. You measure their inventory, how much was it shipped and received, by how many orders you made, how many items were shipped, what's the dollar amount, if it was received, yes or no, was it on time, was it quality, was it damaged or what? So there's all different kind of effectiveness measures. We won't get into that in this course, but I put it in here to be complete. Now, in a couple weeks, we'll be looking at ABC classification, and I introduce it here because it is a classification of inventory. ABC depends on the value of something called the skew. The skew is an acronym. SKU is Stock Keeping Unit. Stock Keeping Unit. Stock Keeping Unit. So basically, it's a skew item. It's a skew number. Let's see here. I don't have any product here. Does this have? Oh yeah, my water here. So this has a barcode. See my barcode there? So that barcode, clink, it's going to have a SKU number in there. I think I think I bought this at Walmart. So that SKU number will be uniquely identifying this inventory item, not this particular item, but this inventory item group. It's going to be a SKU 13682 or something like that. It's going to uniquely identify this item within their inventory. And then that SKU number will have a number of bottles, like 500 bottles, okay, of that type of SKU. And this is blue, and then this is clear, and that kind of thing. Okay, well, high ticket values are high volume is going to be the A items. The low volume are going to be the C items, and the B items are in the middle. Well, ABC classification, which is extremely valuable, very simple, very straightforward, and probably ABC classification is used more than anything else with multiple item inventories. Okay, counting inventory, you could have a full inventory count, like for inventory for income tax purposes, or cycle counting. Cycle counting is you will count the full inventory, but not all at once. You might divide it up in fourths, and every quarter count 1/4, the second quarter count the second fourth, and so over a year you will count the entire inventory, but you spread it out over the year. That's called cycle counting. Now, cost of inventory. Now I'm going to define it here, but I'll be using it as we go through the lecture today, and also next week. Okay. First, carrying or holding. The unit carrying cost is C sub C. The big C here, the big C is cost. The little c is carrying cost. Okay? Now, what this carrying cost or holding cost is, let's back up here. When I order items from my supplier, it goes in my inventory. Well, it costs money to carry that in my warehouse. And so that's called, I'm holding it in my inventory, or carrying it in my inventory. You're either carrying it, holding it, same thing. So it costs money. Overhead, warehouse cost, labor, maybe refrigeration. In other words, it's going to cost money to keep that inventory. Okay, and that's called carrying cost. The second down here is ordering or setup cost. In other words, big C is cost, little o is ordering cost. Now this ordering cost, well, first of all, look at the ordering. The ordering cost is placing an order to the supplier, okay? And that's your purchasing department. The carrying cost is your warehouse. The ordering cost is your purchasing department, your buyers. They're buying it from the supplier. They're submitting a purchase order to the supplier. Well, you have people, you have labor, maybe computer systems, and that costs money too, placing orders. Now, one thing that people get mixed up on here, I'll just say it up front here, the ordering cost is the cost per order, not the cost per item. In other words, let's suppose your unit ordering cost is $10 per order. So if I place an order for one item, it costs $10. If I place an order for 100 items, it's going to cost $10. So it's how many orders do you place, it's not how many items. And so the number of items really doesn't matter for the ordering cost. The ordering cost is the cost just to place an order. An order could have all different number of items in it, any number of items in it. Okay, then you have the item O, also the setup cost. Now the setup cost, instead of ordering it from a supplier, the inventory could also be ordered from within, like a manufacturing requisition. You requisition the production facility to actually manufacture items to put them into your inventory to make the stock operation. So the setup cost is setting it up, is ordering it, and also setting it up to do the production. And sometimes it's a changeover if it's intermittent. Sometimes it's a setup if it's repetitive industries or what. Okay, next is the item or acquisition cost, and that's just C. That's just how much the item cost. Just how much did this bottle actually cost? And so it's the cost of it, not the price, it's the cost. Okay, then you have shortage cost. Back order, buyout here. I put this in here because I do have a back order model for EOQ back order. We're not going to get into that in this course. I think if we had another course on inventory, we definitely would. We would optimize things even with back order, buyouts, subcontract, or all different ways to supply your inventory. Okay, but I just mentioned it here. Okay, now today I'm going to divide things up into two divisions. One, let's back up here. Now, the decision to acquire items from your supplier. There's two fundamental questions of inventory theory. The first is lot timing. When do you order from your supplier? The second is lot sizing. How much do you order from your supplier? How much do you order from your supplier? Cool. Nice comments in the chat, guys. That's really cool, Sridevi. Yeah, such good applications, really good applications. Okay, now this right here is just a summary of what I'll be covering today. So let's get into it. Okay, an inventory policy contains two fundamental questions of inventory theory. How much to order, a lot sizing question, or the quantity ordered from the supplier, and when to order, a lot timing question, or when to order items from the supplier. And notice I'm saying lot, which is the order quantity, and a lot of times I refer to that as a lot. Okay, here's an overview of what we're doing today. Okay, first of all, we're going to be doing constant demand today. I'm going to have three different developments: the fundamental relationship, the reorder point, the economic order quantity. And here's the two fundamental questions: when to order and how much to order. So first, the fundamental relationship is going to have the Q here is the lot size, order quantity. D is your demand, and T is referred to as your time between orders. It's called inventory period. So this is the time between orders, and so that's when to order. Q is the quantity you're going to order, that's how much you order, and so the relationship is going to be this Q to DT. So I'll start with this and develop some concepts and relationships with a fundamental relationship. Then I go to when to order, right here, with ROP. That's called the reorder. ROP is reorder point. And now we have a demand again, but now we have the lead time, the time between when you place an order and receive the order, and then safety stock, and that's the guard against stock out. It's a routine policy to guard against stock out. Then I move over to how much to order, and then I bring this down to EOQ. That's the economic order. EOQ stands for economic order quantity. And notice here, since we're looking at how much to order, it's economic. E is economic, which is monetary. So the SQRT is the square root function, square root of 2 times your demand times the unit ordering cost divided by the unit carrying cost. Okay, so that's the development we'll be doing today. And that's all we're doing today. Okay, but there's 2 ways to represent this. So how do you communicate this? There's 2 ways: a continuous review system and then a periodic review system. Okay. First of all, continuous review system simply says, well, when my inventory, I'm continuously going to review my inventory, and then when that inventory reaches my ROP, I'm going to reorder. How much do I? That's when I order. How much do I order? I order Q. The periodic review system is that I'm not looking at my inventory continuously. I'm going to look at my inventory periodically, like once a week, or once every 6 weeks, or once every month or something. And then that's my T. And then once a month, I'm placing an order, or once every Friday, I place my order. That's the T. That's the time between the orders, 1 week. How much do I order? I order a Q. So there's two different ways of representing our inventory policy of when to order, how much to order. ROPQ and then TQ. And that's what we're doing today. Now, what we're doing next week is we're moving away from constant demand here. We're moving away from constant demand to stochastic demand. And so we'll look at a statistical safety stock or a stochastic ROP. We'll look at a single period EOQ, and then we'll look at a base stock level for the periodic review system. And then to end next week, I'll have stochastic demand, stochastic lead time, and then stochastic demand and lead time together. So we won't get into these last two that much, but I'll refer to them. And some people may want to get into these in the projects. Okay, let's get into the details. Fundamental equation, fundamental relationship of inventory theory. Okay. Omar, is there a preference for periodic or continuous? It depends on the company. It depends on the industry. For example, which we'll get to here, I'll mention this a little bit. The continuous review, you'll do that when you have the capability of looking at your inventory or reviewing your inventory continuously. Because you're going to hire someone, sit there and look at your inventory as it goes down, or do it automatically. And so automatically when that hits a certain level, boom, you say reorder. It's kind of like you put on your phone here. On your phone you say, oh, I want alert. When that thing gets to there, boom, alert, order. And you can do it automatically. That's continuous review. Periodic review is like every Friday, like a small to medium-sized enterprise. You know, the pizza place. Every Friday we're ordering pizza from up on the hill, kind of thing. That kind of thing. Okay. And it depends on the industry. Could you repeat continuous? Yeah, a lot of it is automated. Continuous review is a lot of it's automated. So it'll automatically order as soon as it hits ROP. And so it'll be a person doesn't order, it'll automatically just submit the orders. And it's in the contract. We will automatically do it. Okay, so fundamental relationship. Q is the lot size, order quantity, how much you're ordering. D is your demand, is a constant demand rate. T is the inventory period or time between orders. ROP is your order point. Now QDT in this case is the relationship between QDT is Q equals D times T. I call that the fundamental relationship of inventory theory. It's kind of like back in physics, you had, if you remember in physics in high school, that was my first degree, physics. Distance equals speed times time, distance equals velocity times time, or volts equal current times ohms times resistance, that kind of thing. So you have fundamental relationships, okay? And so this is the fundamental relationship of inventory theory. Well, to develop this, I'm going to do it in two ways. First, I start with an example on how to do the calculations. But then once we see the numbers, then we'll back up, and then we'll represent it with continuous and periodic. Then we'll back up and say, let me show you in a graph what those numbers mean. So that's kind of how I'm developing this. Okay, first of all, suppose our demand for the year is 1,248 items per year. That's the demand from our customers. Now this is a constant rate, so it's prorated. I can divide this by 52 weeks in a year. Divide 1248 by 52, I get 24 items a week. So I can prorate that. And the conversions, the time conversion will be extremely important in this topic. 1 year is equivalent to 4 quarters, is equivalent to 12 months, is equivalent to 52 weeks. That's our time standard. And so we'll go back and forth a lot with that, going back and forth. And then we have 40-hour work weeks. Okay, also, suppose that our lot size is given to be 312. Our inventory period is 13 weeks. So the QDT then goes together with 312Q equals 24 items a week times 13 weeks. And notice I picked 24 because week is in the denominator, and this is 13 weeks. So these numbers have to have the same time units. So the demand has to be items per week if the inventory period is in weeks. So the time units have to be the same or it's incorrect. Okay, and then suppose the ROP is given to be 0. Okay, and then the continuous review then is ROPQ. In this case, ROP is 0, Q is 312, and so 0, 312 is our policy for this problem. And so the inventory policy is 0 through 12. And a lot, not every, all people, companies can do things differently, but a convention that most industries use, and it's a convention in the inventory industry, is just two numbers, 0 through 12. What does that mean? Well, 0 is your order point, and 312 is lot size. Oh, okay. For that inventory, what's your inventory policy? Oh, it's 1080. Oh, ROP is 10 and the lot size is 80. Yep. Oh, ours is 100, 300. Oh, ROP is 100. Q is 300. Yep. Okay. Wow. You wait longer and order more. Yep, we do. Okay. When the inventory equals ROP, order Q, or when the inventory is 0, order 312. And that's how you interpret that. Now for the periodic review, it's TQ. Because ROP is 0, I'm starting with that. Unrealistic. Well, it's not unrealistic. Like, why ROP is 0? Zero is a perfectly reasonable ROP. You order it, and so when would ROP 0 and you would get it immediately? When you have a digital supply chain. You're ordering it and getting it immediately. When you order a song, you have it immediately. If you're ordering a song, when you order something that's digital, then within just a few minutes you have it. Okay, and so when you order a book, that's an ebook. You order it, you have it exactly. So you can order things upstream, or even for the consumer. Okay. So here, it's TQ. Every T time period order Q, or every 13 weeks order 312. And so now my inventory policy is 13 weeks 312. So notice that what's your inventory policy? Well, there's two ways to express it. One way is two numbers. If they're just two numbers, you know it's continuous review, ROPQ. If it's a time and a number, you know it's periodic review. The time is the inventory period, time between orders, and the number is going to be the Q, the lot size. And so that right there is the clue on what type of review system that you're operating under. Okay? Okay, that's how you calculate it. That's how you express it. Now let's look at some concepts. Let's go a little bit deeper. Okay, sawtooth curve. Well, this curve here represents the fundamental equation Q equals dt. A lot of times it's called a sawtooth curve because it looks like the teeth of a saw. Well, here's the time. The time is in weeks here. Here's my inventory level over here on the left. And so at time 0, I have my 312, my lot size of 312 coming into my inventory. So my inventory level jumps to 312. Then as time goes by, demand will take items out of my inventory continuously at a constant rate, and that rate is 24 items a week. And so it's continuously decreasing until it hits 0, my reorder point. Boom, I reorder again, I get 312. Then it goes away, boom, 312, boom, 312, okay? And so this just illustrates the sawtooth curve, where the 0 here is the reorder point. The inventory up here is the lot size Q. the slope of this line is my rate, my demand rate of 24 items a week. And the time between orders here is 13 weeks, 13, 26, 39, and 52. So my inventory period is 13 weeks. So this little graph here represents, is a good representation of the sawtooth curve. And I might mention in passing that this sawtooth curve represents the concept of the sawtooth curve in inventory. It does not really represent real inventory. When you look at inventory, rarely do you see that sawtooth configuration. You're going to see something that's kind of like this, okay? Because in real life, things are not perfect. Things are late, things come in late or early, or you have damaged things, or so all different things can happen. But that doesn't mean this concept still does not underlie, and your techniques are based on this concept. So this just illustrates the concept. Okay, now let's consider the definitions for the annual planning horizon. Okay, so our planning horizon is for a year. Notice this is 52 weeks. Well, 52 weeks is a year. So this is 1 year. Okay, our inventory period is 13 weeks, but this is 1 year. Suppose that's our planning horizon, an annual planning horizon. Okay, well, during this year, I've received an order and used up an order. I did that 2, 3, 4 times. So the number of orders that were received and used up is called the order frequency, and it's 4 per year. There's 4 during this year. And that's referred to as the order frequency. And notice the order frequency has time in the denominator. Okay, well, that's good. But what's my inventory period? My inventory period is 13 weeks. So again, time is going to be extremely important, and conversions of time. For example, if I could say in this graph, what's my inventory period in weeks? The answer is 13. Well, 13 weeks is 1 quarter. So what's my inventory period in quarters? The answer is 1, because it's 1 quarter. 13 weeks is 1 quarter. 13 weeks, 1 quarter is the same thing. But then, what's my inventory period in years? Well, over an entire year, how much is 13 weeks out of 52, or 1 quarter out of 4? It's going to be 1/4. So it's 1/4 of a year. So at this point, a lot of times it's really easy to say, oh, it's 4. No, it's not 4. It's 1/4 of a year. Because 1 quarter is only 1/4 of a year. There's 4 quarters in a year, but one of those quarters is only 1/4 of a year. So you got to be really careful with the conversions. Okay, so if my order frequency is 4 per year, then my inventory period is 1/4 of a year. Okay, and notice the year. Let me do it this way. T equals 1/4 years. Okay, and notice this year, the years are in the numerator. For the order frequency, it's in the denominator. So therefore, notice the reciprocal nature. So again, this is a rule. It's a principle. The frequency is the reciprocal of the periodicity, and the periodicity is the reciprocal of the frequency. F is 1 over T, and T is 1 over F. Now, did you notice that I didn't say period, I said periodicity? Sounds like forecasting? Sounds like time series analysis? It is. This is a time series. A lot of times people call this the inventory periodicity, because that's the repeatable pattern of our inventory. That repeatable pattern depends on when you place an order. And so it's over time. Okay, so that's the period of an inventory by how often you place the order. So therefore, my Q is DT here. Now that I have an identity of my T and my F, my inventory period T and my order frequency F, now I can substitute 1 over F in for T, and now I have 2 expressions here for the fundamental equation. So yes, the fundamental equation is Q equals dt. But, comma, I can also say the fundamental equation equals d over f. They're the same thing. So there's two representations of the fundamental equation. But then I can solve for t and I can solve for f. And notice my inventory period is Q over D. My frequency is D over Q, the reciprocal. Okay, this just represents a lot of relationships that we'll be using. And I'll use them, I'll say, from the fundamental equation, and I can quote any one of these 6 terms. Because all 6 of these come from the fundamental equation. That's one thing. The second thing, turnover. Inventory turnover technically is defined as how much inventory comes in, how many items come into your inventory and then go out of your inventory. So in this first quarter, 312 came in, then over one quarter, 312 went out of my inventory. So the turnover in this first quarter is 312. So my inventory turnover in one quarter is 312. That's how much came in and went out. Now, what's my inventory turnover the first half of the first quarter? Well, 312 comes in, but halfway through, only half of this goes out. Well, half of 312 is 156. And so if 312 comes in to my inventory, but over half of a quarter, only 156 goes out of my inventory, then my turnover is 156. Because it doesn't matter how much has come in. What counts in inventory turnover is how many items have come in and gone out. So here I have 312 come in, 312 come in, and over 6 months, half a year, what's my turnover? Well, 312 has come in and gone out twice, so that's 624. Closely related, and so since there is no negative inventory, there's no zero inventory for a period of time. So in this simple example, and the examples that we'll be using in this course, the inventory turnover can be equated with our demand rate over time. So again, our turnover here, notice our demand here has time in the denominator. Therefore, our turnover will have time in the denominator. Okay, turnover per quarter, turnover per year, turnover per 6 months, that type of thing. Closely related to turnover is something called the turnover rate. Okay, and there's where you take your turnover and then you divide by Q over 2. And now Q over 2, if within the first quarter, if I start with Q and I end with 0, well, Q plus 0 divided by 2 is Q over 2. That's my average inventory. And so Q over 2 represents my average inventory throughout this year or a quarter. So for the planning horizon of 1 year, Q over 2 represents my average inventory. So the turnover rate is my turnover during a period divided by the average inventory, or how many times I have turned over my average inventory. So remember, a turnover rate is not the turnover. Okay, now I got to be careful here. Some people call this a turnover rate. Some people call this a turnover index. Some people call this a turnover ratio. Some people call this turns. Some TURNS. Some people call this turnover. Okay, so whatever term they use, be very careful to know what the equation and relationship is and what the units are. Is it really a turnover rate? The rate at which we're turning over our average inventory. Okay, so our average inventory is 156. So what's our turnover rate in this first quarter? Well, the first half of the quarter, I turn over my average inventory. The second half of this quarter, I turn over my average inventory. So over 1 quarter, I've turned over my average inventory twice, so my turnover rate is 2. So every quarter it's going to be 2. 6 months, my turnover rate is 4. So over a period of a year, what's my turnover rate? It's going to be 8. So have you turned over your inventory 8 times? No. You've turned over your average inventory 8 times. So if you've turned over your entire inventory, it's your average inventory, whatever that average inventory is. Now, notice I can do some algebra here and bring the 2 up, 2 over D over Q. D over Q is 2F. For this course, for the simple examples we have in this course, and just this course, especially this lecture, Inventory-1, the turnover rate on everything we do is the same as 2 times the frequency. So the turnover rate then will have time in the denominator. Now, you probably are familiar with turnover rate in other courses and other classes, like in accounting. What's a good turnover rate? Well, you want to have a high turnover. You want to have a high turnover rate. Well, if you make that thing really, really high, then what would you do to this equation? Well, the demand is given. You have control over Q. So where would Q go to increase the turnover rate? If your turnover rate is going to increase, then Q is going to get small. So you're going to decrease Q, right? So if you decrease Q, you increase your turnover rate. You're turning over your inventory faster. And so a turnover rate is a measure, a metric of inventory. But there's another measure, and that is efficiency and cost and stock out. So cost of inventory, cost of stock out, and stock out. Well, if you decrease your lot size Q, then the probability of stock out goes up because you have less inventory. And so when you have less inventory, the probability of stock out increases, so your risk goes up. So a very high turnover with no stock out is a very efficient inventory system. And we'll talk about that here a little bit later. Actually, a couple pages down. So you got to be careful when you look at only one metric, turnover rate. What about stock out level? What about carrying cost? What about ordering cost? So there's a number of things you're looking at to manage your inventory, having a good management of your inventory. Okay, the next one is going to be the reorder point. So the reorder point here, ROP is demand times lead time plus safety stock. And so first I copy the fundamental equation again, but now I'm going to introduce lead time, which is the time between when you place an order to your supplier and then you receive the order. And if you've ordered things through email, I guess people are ordering a lot of things now online through Amazon or email or mail order catalog. You order it, and it'll tell you when the arrival date is going to be. Well, that time between ordering it and receiving it, that's going to be your lead time. Okay? And then safety stock is carrying inventory, again, to guard against stock out. And we'll define that here in just a minute. And so the fundamental equation of our reorder point, ROP, is demand times lead time plus safety stock. And we will revisit this next week as well. I mean, next week when we get into stochastic. Okay, let's do the example. I copy this from above. Demand is 1,248 items a year, 24 items a week. The lot size is 312, inventory period is 13 weeks. With Q equals DT, it's 312 equals 24 times 13. So I copied that from above. Now, for the ROP, suppose the lead time was 3 weeks. 3 weeks. So therefore, the ROP for a safety stock of 0 is 24 times 3. Now notice this is in weeks. So therefore, I want this in weeks. So 24 times my 3-week lead time plus my safety stock of 0 yields a reorder point of 72. Now, my reorder point, if I increase my safety stock, say, to 10, then I have my 24 times 3 again, plus 10, which is 82. So now, depending on what my safety stock is, my reorder point is directly related to safety stock. Say safety stock goes up, then the reorder point goes TQ. I have 13 weeks, order 312, and so my inventory policy then is 13 through 12. So here, notice the difference between these two. With a safety stock of 0 or 10, remember safety stock is part of ROP, and there it is. But for the periodic review system, safety stock really doesn't enter into the T or the Q. But is it there? Yes, it's there. Okay, it's there because the actual order is not necessarily on the T is every 13 weeks. But when you place the order, it's not at 13, 26, 39, and 52. It's 3 weeks. The lead time is 3 weeks. Where's it at? The lead time is 3 weeks. It's 3 weeks before this. So I'm going to start at 10. And then it's going to be 10, 23, 36, 49. So it depends on when you start. Okay, so it's there. It just is not part of the policy. Again, you have to know what you're looking at and what you're doing. Okay, so let's come to these curves. And let me throw some curves at you. A slider and a screwball. Anyway, let me throw some curves at you here. Okay, let's look at these curves. Sawtooth curve. Let's enlarge this. Let's start with this one over here. I've made so many videos this year. It's kind of fun, but sometimes I get kind of silly. Okay, here we go. Let's make this bigger so we can, there we go. Okay, again, just to illustrate what's happening here, here's 13. My lead time is 3 weeks here. My demand rate is 24 items a week. So right here at week 13, my inventory is 0. If I come back 1 week, since my demand is 24 items a week, if I come back 1 week to week 12, my inventory is going to be 24. Because from 12 to 13, the 24 goes away, it goes to 0. If I come back 2 weeks, 13, 12, 11, it goes up to 24, 48. If I come back 3 weeks, it goes up to 72. And that's why it's 24 times my lead time, because that tells me how much inventory I need that is going to go away in 3 weeks. And that's why it's my lead time times my demand rate. Then I add my safety stock to get 72. So there's my 72, 312. So it's just like backward scheduling is all it is. Okay, now as some of you already have thought about it, and what happens, see this comes all the way to 0. And so every inventory period, at the end of that period, our inventory is 0. Okay, well if our demand is nice and constant with no glitches, no variability, which usually never happens. If there's demand there when we have 0 inventory, we're going to have stock out. And stock out is costly. You lose sales. Sometimes you'll lose customers. You'll lose branding. You lose image. And it has been estimated that on the average, stock out costs are like 8 to 10 times greater than inventory cost for the same amount of inventory. In other words, if you're stocked out 10 items or you carry 10 extra items, the carrying cost is 1/10 the cost of the stock out cost, because when you calculate everything in. So stock out costs are costly. Usually you don't want to run out of inventory. Sometimes it doesn't matter as long as it's part of the business plan and business. Okay. Yeah, basically you're right. When you're stocked hot 72, order 312. Yeah. Cha. Okay. When it hot 72, you got it, Craig. Okay. Let's see. Okay, so to guard to get this stock out, what people will do is I don't want it to be 0. I'll be much happier. I feel much safer. I don't want my inventory to go all the way to 0. I want it to go just to 10, so I have 10 items of inventory just to guard against my stock out. I'm expecting it to be 0, but what if when it goes to 9 or 8? Well, I have 10 items in there to guard against running out of inventory. So what people will do then over here on the right, they say with a safety stock of 10, what that does to my inventory, my sawtooth curve, is right here, see this line right here? That's 10 items of inventory I'm carrying all year long, theoretically, to guard against stock out. So essentially, I take my sawtooth curve and I move up 10. It just moves up 10. Yeah, I'm kind of glad they do, Craig. So ROP is when you... Okay, you can run with that. Anyway, so everything just moves up 10. The average inventory was 156, now it's 166. The maximum inventory over here is 312? Now it's 322. The ROP was 72, now it's 82. So everything shifts up on the curve, but everything doesn't change. For example, the inventory period is still 13 weeks. That does not change. Something else doesn't change, and that is the lot size Q. 312 does not change. Now over here it goes from 0 to 312, but notice when the safety stock is 10, this doesn't go all the way to 0, it goes to 10. So it goes from 10 at a minimum to 322 at a maximum. So from 10 to 322, that's the lot size, which is 312. So some things don't change and some things do change. Now, some terminology in this that we'll use next week. And that is the probability of a stock out, alpha, is called the stock out level. The probability of having stock out within an inventory period is called the stock out level. And that's a probability. We'll calculate that next week when we get to inventory number 2. And Greg, if the safety stock is 100, what would that do to the curve? It would just move it up. It would move it all the way up to 100. In other words, this line right here, which is 10, this line will be up here to 100. And this will be up here to be 412. Okay? Or 412. To shift everything up. Okay. So, and then 1 minus the probability of stock out is called the service level. So remember, the ROP here is directly related to the safety stock. The ROP is directly related to safety stock. So if the safety stock increases, the probability of stock out decreases. So the safety stock and the stock out level are inversely related. But the safety stock and service level are directly related. Well, hopefully that makes sense. The more inventory you have, the better you can service your customers. Okay? And so the safety stock increases, your inventory level increases, your service level increases. If the service level increases, that logically implies the stock out level decreases. The probability of running out gets less and less and less when you carry more and more and more safety stock or reserve stock or buffer stock. And we'll be calculating stock out level here next week. But here I just have the definition of it and the relationship of the stock out level and the safety stock and the service level and the safety stock. So here we have 72,312 and here we have 82,312 for the very same inventory item. The only thing that's different is the safety stock. Which one of these will have the greater stock out level? The 72,312, the left one or the right one? Which one will have the greater stock out level? Remember, stock out level is inversely related to the safety stock, so the left one will have a greater stock out level because it has a lower safety stock. And the safety stock if that's the only thing that changed, the first number has safety stock embedded in it. If you're only changing safety stock, then you know the safety stock here, 82,312, is greater than 72,312. And so 82 has a greater service level. That means 72 has a greater stockout level. Okay, and that's some of the relationships we'll use next week when we start interpreting this and applying it. Now, before we go on, here's a good question. Does that mean that the first order is for 322? That good question. That is always asked. People always ask that. And so the idea here, again, it allows me to make another really important point. This curve right here represents the concept, the relationship and concept of the sawtooth curve and safety stock and the reorder point. Now, this is, once it's set up, this is how it's going to run. So when is it set up? And you're right, Raphael. Maybe you order 312 at the beginning. Well, when was the beginning? You usually, there is no beginning. It's kind of like circular. Like walk into any company and they already have inventory. And so the question is, okay, well, when do I order next? Well, we want to say, and also the demand changes. And so every time things change, you calculate your reorder point. So let's suppose you have 200 items of inventory. Okay, you have 200 items of inventory in here. And so the idea here is that, what was your inventory policy for before? I don't know what it was. I really don't know. But I have my demand forecast. I have a new forecast for my demand. I have a policy of 82,312. That's what I'm going to use going forward. So boom, it's going to be 82,312. Fine. What was it before? I don't know. It doesn't matter. Soon as that hits 82, soon as that hits 82, boom, I'm ordering 312. What was it before? I don't know. But I know from here on out it's going to be 82,312. I hope that answers it, if you see what I mean. Because, yeah, somewhere in the past, they've ordered things. Maybe they ordered too much, too little. Maybe they didn't order enough. Maybe whatever. Maybe they didn't have safety stock. Maybe they're doing the left one and now they're doing the right one. However, whatever's happening. But once you have this policy, that's the policy today moving forward. For example, you don't know what your policy is. It says, oh, okay, we'll know what it is next week. I have to order today. Well, then order something. Okay, I order 200 items today. Fine. Now next week, we have our policy now. What is it? It's 82,312. Fine. When that hits the 82, then we'll start the policy. Okay. Hope that answers it. Okay. Okay. EOQ. And the EOQ stands for economic order quantity down here, economic order quantity. And since the economic part of it, we're trying to minimize cost. So there's where the costs come in. So I'm copying the fundamental equation, the ROP equation, and now I'm bringing back the unit ordering cost, unit carrying cost. I've already defined it. And here's my equation, square root of 2 times D times C sub over C sub C. Okay. Now, before I get into developing this and describing it and all different ways of developing it, I'm going to emphasize that EOQ is not a number, it's a concept, it's a model. Actually, it's a concept. And the concept is minimizing cost. And to emphasize that, I have 10 different EOQ models here. We're doing the basic model today. Then I'm going to be doing the quantity discounts before we leave today, and that'll be the end of today. Now there's a continuous replenishment, planned back orders. That's for constant demand. Then you have stochastic demand. We'll do this next week. Well, I just have single period and multiple periods. We'll be doing single period and multiple periods next week. And the multiple periods are going to be a continuous review and periodic review next week. Or you have irregular demand, least total cost, PPA, PPB, and the Wagner-Witten algorithm. So these are pretty much heuristic methods. The Wagner-Witten algorithm, this is a dynamic programming technique which will minimize costs by a dynamic program assuming irregular demand. Irregular is just, it's a stochastic, but it's like a uniform distribution. But it's highly irregular, highly volatile. Okay, there is no real, well, there is. It's really just a uniform distribution with high variability. Okay, I want to emphasize that there's 10 different models here. These are only 10. There's others. So EOQ is a concept. Okay, let's get into it. First, I want to generate a little bit of motivation for EOQ. What it is, what we're after. So here's my unit cost, acquisition cost, unit ordering cost, unit carrying cost. Remember, acquisition cost is just how much you pay for it, is the cost of the item. Ordering is your buying and purchasing department, your buyers. Carrying cost is your warehouse. And then up here, you can expand that to an entire planning horizon, say a year. And that's the demand over time times how much each of those cost. I call that my total acquisition cost or total item cost. And then my unit ordering cost is the total order frequency per time period for a month, quarter, year, whatever it is, times how much each of those orders cost. That's my total ordering cost. The carrying cost is my average inventory over whatever time interval you're looking at, times how much it costs to carry each of those items over that time. And that's my total carrying cost. If I add these last two together, ordering and carrying, I call that my inventory cost. If I order all three of them together, I call that my total cost. So there's definitions. So let me show you some motivation on how these all work together. Let's take this sawtooth curve. Let's suppose that at time 0, I order 100, and this is quarter 1, quarter 2, quarter 3, quarter 4. So 4 quarters over this year, my order frequency is 4. I can take that 4, put it here, times C sub O, and I'll have my total ordering cost. My total ordering cost. Okay, but my average inventory then is 50. 50. I can take that 50 and put it here, times my unit carrying cost per item per year, because over 4 quarters, and that's my total carrying cost. My total carrying cost for the year. So I have my ordering cost and my carrying cost. Now, suppose I double my lot size to 200. Well, that's going to last twice as long. My order frequency drops from 4 down to 2, so my ordering cost here decreases. But since I'm ordering 200, my average inventory jumps from 50 to 100. My average inventory increases, so my carrying cost increases. So one goes up and one goes down. Conversely, if I decrease this from 100 to 50, my carrying cost goes down and my ordering cost goes up. Notice the inverse relationship between the ordering cost and carrying cost when I change my lot size Q. So when I change Q, these two are inversely related. Well, remember the very first lecture I talked about break-even analysis, where you're going to have a break-even, where you have the break-even in there. And so at that break-even where these two costs come together is called, we want to find a Q that minimizes the sum of those two costs. And that's called EOQ. And that's going to minimize the sum of those two costs. So that's the idea. So increasing and decreasing Q until the sum of those two costs is minimized. So that's the concept. So now let's develop it with a basic EOQ model. Okay, I'm gonna mention this. It's not going to be part of this course unless you want it to be. You can look at it if you want. This first one is using calculus, and it's interesting because I grew up with calculus, and calculus a lot of times is becoming less and less required in courses in school, and naturally I disagree. I think calculus should be taught in middle school, but anyway, maybe not all the different transcendental functions, but the concept the concept of limits, the concept of if you keep doing this, it's going to converge to this. Okay, that's the concept of calculus. Anyway, the idea, let's get back to this. The idea is the total cost equals the carrying cost, ordering cost, acquisition cost. Well, the carrying cost is your average inventory times the unit carrying cost. And average inventory is Q over 2. The total ordering cost is the order frequency times the unit ordering cost, and the order frequency is D over Q from the fundamental equation. The total acquisition cost is the total items, which is D times how much each of those items cost. So now my total cost is made up of my carrying, ordering, and acquisition or item cost. So now I want to minimize my total cost because EOQ is economic, which means the minimum cost. To minimize this, I have this first expression is linear in Q. The second expression is inversely related to Q. The third expression is independent of Q. So when you have a nonlinear function, you take the derivative, say equal to 0, solve for Q. And those of you with engineering degrees, you can sit here and do this quickly. You can probably do it in your head. So actually, this is taking the derivative. This is C sub C over 2. This is a minus D C sub O over Q squared. And so this is Q squared. So bring the Q to the other side, set that equal to 0, and take the minus sign out. So you have C sub C over 2 equals C sub O D over Q squared. Bring the Q squared over here. Bring the C sub B over 2 over here. Be C sub B over 2. 2 over C sub C. And boom, then you take the square root to get the QOQ. You could probably do it in your head. The point is, you don't have to. don't hurt your. You don't have to. It's the square root of 2 times your demand times the ratio of the ordering cost to carrying cost, and that will minimize this cost function. That's the concept you have to take away. Okay, EOQ simply minimizes the cost, that inventory item, when you're pitting the ordering purchasing department and your buyers with the warehouse and your material managers. When you're balancing those out, that EOQ will minimize those two costs to the organization. And that's basically what that means. Okay, so let's develop this a number of ways before we leave this evening, because EOQ is a very interesting concept. So it's simple, but let me just show you. Okay, again the example. Demand is 12,480 items a year. Omar, so it doesn't depend on C. I'm so glad you asked that. The answer is no, it doesn't. Not here. But later it will. Actually, again, I'm so glad you asked that, because C, it doesn't matter how much it costs until you get to quantity discounts. Then it does matter. Then C does matter. Interesting. And this is what we'll end with today. Okay. Okay, we'll do this, quantity discounts, then we're done for tonight. Okay, here we go. 12,480 items a year. Divide that by 52, get 240 items a week. The ordering cost, suppose this is given to be $52 per order. That's how much it costs to place an order in the purchasing department. The carrying cost is $1.20 per item per year. And notice this is prorated over items and time. In other words, one item over a year is $1.20. 2 items over a year is $2.40. 1 item or 2 items over half of a year is $1.20. And so it's prorated over the number of items and how long you're carrying it. And then the lead time is 3 weeks and the safety stock is 10. So the ROP now, demand times lead time plus safety stock, is 730. Okay. The EOQ, putting this in here, just plugging and cranking, I'm putting the 12,480 items per year in there. So I have the year there. Now 52 here is my ordering cost. See, I put that there. That's for my ordering cost. I divide by my carrying cost. Well, my carrying cost also needs to be in years. Since my carrying cost is $1.20 per item per year, and that's what I put in the denominator, then my demand up here then must be in years. Again, the demand time units in the numerator has to match the time units in the carrying cost in the denominator. Those times have to match. And they do, so I got the right answer, 1040. 1040. 1040. Reminds you of your income tax next month, right? Okay, now that's the EOQ. What about the inventory period? Well, T equals Q over D. So for Q, it's 1040. D is 12,480. So that's how many years there is. Now I can transform the years to weeks. I can transform the weeks to months. And the way I do that is years to weeks. Well, how many weeks are in a year? 52. So if I multiply this by 52, this is approximately 4 1/3 weeks. How many weeks in a month? 4 1/3. So you have to be careful. It's not 4 weeks per month. It's 4 1/3 weeks per month. Okay. Or what some people have done, instead of just taking the 1040 and put it in for Q, they'll take this equation and put that in for Q and then reduce it down. And the T then, the optimal inventory period becomes the square root of 2 times my ordering cost divided by my demand times my carrying cost. It'll give you the same numbers. The reason they do that is sometimes then the continuous review is this is called the economic order quantity, and sometimes this is called the economic order period. It's the optimal period which minimizes cost, and this is the optimal lot size which minimizes cost. Again, by the fundamental equation of inventory theory, it all ties together. Okay, so we have 73 1040 or 1 month 1040 for the continuous review and periodic review. Sound good? Okay, now let's go to the graph, and here comes some really powerful, very simple takeaways for everyone. I notice there's some math in here, and there's some calculus, and there's some trigonometry and conic sections with parabola. Well, I'm going to get into some hyperbolas here. But the point is, the important thing in business is the conceptual takeaways. Okay, we all have our all different disciplines, but in business, everybody can come away with a takeaway. And I'm going to talk about some takeaways here. Here we go. For the safety, and graphically, if you can think in graphs, for the safety stock of 0, the total inventory cost is the carrying plus ordering cost, which is the average inventory Q over 2 times C sub C plus D over Q times C sub O. I put the numbers in here and I do the arithmetic, and notice these two numbers are the same. Here's what's happening. Here's this graph here is cost, and over here this is Q. This is how many items my order quantity. How much am I ordering from my supplier? I'm ordering 100 tables, 1,000 tables, 1,000 tables. Okay, now notice this line right here is linearly increasing, nice and level. That line right there is my total carrying cost because it's Q over 2 times C sub C. It's linear in Q. As Q increases, the total carrying cost increases in a nice level fashion. Now this line here is not linear. It's coming down. That's my total ordering cost, and that's D over Q times C sub O. And notice Q is in the denominator. So as Q increases, the total ordering cost decreases. And that's the graph of it. That's what it looks like. So when I add these two together, I get my total inventory cost. And that's exactly what this curve is right here. Now the minimum of that curve, if I had a ball bearing and dropped it in here, bing, 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 it'll stop right here because that's the minimum. Now that minimum corresponds with that Q, and that Q is EOQ. So the EOQ will minimize the total inventory cost when the safety stock is 0. And again, Omar, just like Omar said, Q is not part of this yet. It will be in a minute. But that's a concept, okay? But notice something else. When you come down here at EOQ, okay, this is a Q, but it's called EOQ, economic order quantity, because this is a special Q, the one Q along this axis, such that my inventory cost is minimized. For a Q for minimum is called the EOQ. But something else, at this Q, at that minimum, come down here, these two lines cross. When they cross, that means they have the same cost. So at EOQ, the total carrying cost at EOQ equals the total ordering cost at EOQ for safety stock of 0. And that's what I'm showing up here. They're both 624. So when the safety stock is 0, the carrying cost and ordering cost will be the same. So theoretically, again, that's a concept. And that concept is extremely valuable. 2 examples, 2 takeaways. First of all, that's a takeaway. The cost for an item, for your inventory, for your tables over here, or your chairs, or your picture frames, the carrying cost and ordering cost, when they're the same, then your lot size is an EOQ. Okay, another takeaway. Suppose you do not know what your carrying cost is, and you do not know what your ordering cost is. You just don't know. You just don't know. So, what happens is that, okay, go into any company, almost any small and medium-sized company, some large companies, say, oh, this inventory item, how much is the ordering and carrying cost for that item? Says, I don't know. I really don't know. And some of them who know what they're talking about say, I don't have to know. Interesting. Why? Here's why. Pick a lot size. Pick a lot size. Let me pick 120. Okay, I place 120, and when they go away, I place it again. And when they go, I just pick an inventory policy. I go away, I pick it again. Okay, and then at the end of a quarter, end of a year, you go to the accounting department and say, how much did my carrying cost? How much was my carrying cost? Oh, well, the total carrying cost for that item is going to be $1,000. Okay. Oh, okay, $1,000. Okay. Well, what was your lot size? Well, my lot size, I ordered 120 each time. Oh, let me make this easier. I ordered 100 every time. Okay. Let me see here. Okay. Well, then if that's 100, then 100 over 2 with a safety stock of 0 is 50. If that's 50 and this is 1,000, then what is 1,000 divided by 50? It's 100 over 5, which is 20, right? So my carrying cost is $20 per item per year. So you can back out your unit carrying cost. I probably should have used an easier number. Suppose this was $100 and my lot size Q was 20. So 20 over 2 is 10. 100 divided by 10 is 10, so that's $10. My point is you can back out the unit carrying cost. Okay, what I have, 20? It's supposed to be $20. Yeah, it should be $20. Okay, well, that's one item. Can you do that for every item? Sure you can. If you have the total costs and you have your lot size, you know your lot size, you've ordered it. You look at your invoices. Every invoice you ordered 100 every single time. Okay, I got that. And then at the end of the year, they say, here's how much that item cost to carry. Got it. So if you say, oh, I'm observing that this right here is, say, $1,000, and this is $500. If that's 500 right here, and suppose I ordered 100, so 100 over 2 is 50, then 50 into 500 is going to be 10. So my carrying cost is 10. I can back out how much that carrying cost was for that item. Same thing for your ordering cost. You say, oh, I know last year I ordered this thing 10 times. I have 10 invoices that I ordered from my supplier. Okay, well, 10 invoices, but then the whole cost right here, this is $1,000, so this is 500. If this is 500 and this is 10, then this is going to be 50. So my ordering cost is $50 for that item. So I can back out what my unit carrying cost is per item in my warehouse and the unit ordering cost is in my purchasing department. So those can be used as performance measurements. For example, shouldn't every item have pretty much the same carrying cost in the same warehouse? If one is higher than the others, there's a problem. If an ordering cost is higher than the others, there's a problem. Okay, the reason I bring this up, true story. Years ago, I was consulting, and I was asked to help with their inventory. I go, sure, give me the numbers. The accounting department gave me their number, or their computer department had everything was integrated, so they gave me all these numbers. And a week later, I looked at the numbers. They came back and says, yeah, there's some things we can do. And I says, but I found a problem. What's the problem? Well, you gave me all these numbers for all of these items. Now there's a group of items over here, group of SKUs, let's say, and these SKUs, like 3 or 4 of them, 4 or 5 of them, I think there's like 3 of them. These SKUs over here have a huge ordering cost. In other words, so let's use these numbers. They're supposed to be around 50. When I look at these other items, there's 50, 52, 48, 55, 52, 53. EOQ confusion in general. I'll come back to that, Craig, in just a minute. Actually, if others are confused about what EOQ means, this is not going to make much sense. Let me go back and answer that again. If I order too much, I'm carrying too much here, and then down here, I'm carrying too much, but I'll order less. Okay, if I order too little, then I'm ordering too many times and I'm carrying too little. Let's come back up here. Let's suppose we have a order frequency of 4. 100, so the demand for the year is 400. What if I ordered 400? I order only one time a year, 400. So my ordering cost may be really small, but my carrying cost is huge, right? Because I'm carrying all this inventory, and that costs money to carry. On the other hand, let's go the other extreme. Let's order one at a time. So every hour we're ordering something, okay? So inventory carrying cost is really, really small, virtually zero, very, very small. But I'm ordering so much, my ordering cost is huge. Where there's something somewhere between 1 and 400, my lot size in there, to where these costs are going to come together, where they're going to have a minimum. So too much is too high, too little is too high. Ordering too much, the carrying cost is too high. Ordering too little, the ordering cost is too high. When somewhere between 1 and 400, this is going to come down like this, and there's going to be some lot size Q where there's going to be a minimum between the sum of those two. And that lot size is called EOQ. And that's essentially what this is saying. If I order too much here, I'm carrying a lot, but my ordering cost is less. If I order small amounts, then my carrying cost is less, but my ordering cost is more. Okay, and so the question is, if you don't know what drives order cost in real situation, is that labor to pay purchasing staff? There's a number of things. Well, it depends on the industry, depends on the company, how efficient their ordering department is. First of all, it depends on the items. If there's C items, B items, then it's going to be efficiency. If it's A items, sometimes it's going to be making sure you have the right vendors. What drives ordering costs in real situation? A lot of times it is the overhead of your purchasing department. Okay, but also a lot of times if they want to try to streamline it, they'll have a lot of computers up there. If you have high ticket items, let's say in earth moving equipment like Deere or Peterbilt type of huge large ticket items, you might have contracts. So you have lawyers. Yeah, you'll have legal fees to make sure those contracts are being monitored. And so all of that ordering, there's a huge amount of overhead in placing orders. Okay, and the other is identifying suppliers and vendors. And so sourcing and identifying vendors upstream, you're going to have projects in that area and monitor, and also governance, which is referred to as a governance policies on governing your upstream suppliers. You might even have a consortium. There's different types of information systems of consortiums or content consortiums or private type private upstream called constellations upstream. So that would have a very high cost as far as the IT is concerned, in order to have that efficient. And so there are, in the small to medium-sized enterprises, it's just having to place the order. Okay, someone's got to have to sit down, write this order, and place it. Okay, and so the cost may not be that much, may be small, so you might be able to order it fast, but then whoever's placing that order is not doing their other job. Because usually in a small to medium SME, small to medium enterprise, they're doing more than one thing. I need to place an order. Okay, we'll place the order. Okay. If you're placing too many, I'm taking all my time placing orders. I'm not really making the product. So it really depends on the company. I hope that answers it. The difference between C sub O and C, well, C is just what the item cost. In other words, coming back to my bottle, suppose this bottle, the actual cost of this bottle was $1. Okay. In other words, if I'm going to buy this from whoever I bought it from, I don't know who it's from. It's a bottle company up here. If I buy it from the bottle, if I'm going to buy 10 of these, I give them $10. That's just how much it cost. Now, C sub O is an ordering. I'm placing an order for 10 bottles. When I place that order for 10 bottles, the order costs $50 to place the order. Oh, but each dollar is 10. Each bottle is $1. So if I place an order for 10 bottles, that order is for 10 bottles, but the order costs $50 to place. Okay? So one is placing the order, the other is actually the cost of the item. Okay. Suppose you didn't know C sub C, you didn't know C sub O. So let me go back to these examples. And here's how this is used. At the end of the year, ordering cost is more than carrying cost. If the ordering cost is more than the carrying cost here, then the Q is too small. You need to increase Q. If you increase Q, then the ordering cost and carrying cost is going to start coming together. Okay? And you keep increasing and decreasing Q till these come together. Boom, you know you're at EOQ. So then up here, what I just explained is exactly the basis of something called the least total cost method or the part period algorithm. Craig, that's pretty much true. So you're not going to order 10 if it costs $50. You'll order 500 or 1,000 or 3,000 because that $50 has to be spread over each bottle. You're right. You're right. I was using that as an example. So many times in companies, they don't look at don't look at the cost of operations. They go, wait a minute. For example, I was sitting in a meeting one time. They're talking about the cost of implementing new computer systems. They said, okay, the computer system costs this. We hire these people. So when they got done, they had this is how much it cost, And they said, so that's the cost to the company. And I was in this meeting. I raised my hand. I go, wait a minute. When you implement that, it takes this long for it to be online. And during that time, everyone's not being productive. Once it's online, there's going to be a training session where the productivity comes back, but not 100%. And by the time it gets to be 100%, it may be weeks before people really understand how to do this. Where's the lost sales? Where's the lost efficiency within the organization? And the answer was, we don't count that. Because if we ever did count that, we never would implement anything. I said, maybe you better start thinking about it. You shouldn't dismiss it. Maybe you should minimize the introduction of computer systems, because computer systems can just devastate an organization if not done properly. If done properly, they'll just take off. Okay, that's a different. Sridevi, freight comes under C sub O or C? Well, it really depends. Usually it's C sub O, but it could come under the C depending on the contract. Depends on the contract with the supplier, okay, and that gets into contract negotiations. Sometimes it's the cost itself. They'll fold the freight cost or the bill of lading into the cost. Sometimes they don't. But even if it's in the cost, but even though the freight's in the cost, you still have cost of ordering. That's internal cost. They're not going to pay for your people placing the orders. Okay. Good questions. Very good questions. I like them. I hope I'm answering them good enough. A lot of these really depend on the company. When you get the concept and idea, once you start working, these answers will be specific to your job and your company and your suppliers. Okay, but the concepts are pretty universal as long as you can understand them to apply them in the right way. Okay, so that's the second thing. You can back out these things. So there's a number of things you can take away here. When you have these costs that are not equal, then you know there's something wrong in there somewhere. If the carrying cost is too large, you're ordering too much. You need to lower your lot size. If the ordering cost is too large, then you need to increase your lot size. And so in other words, the lot size that's going to be optimal is going to be related to the carrying cost. In other words, if it's too big, the cost is too big. If it's too small, the cost is too small relative to the ordering cost. Okay, I talk about, Craig, we introduced a new CRM, integrated accounting system. The rollout was so bad, it cost my company thousands of dollars a month for 9 months. This is a... previous report. This is I talk about this in my supply chain management course. There's articles, there's research articles that illustrate, and also there's examples, case studies, where, for example, they'll buy an ERP system or a CRM system or a supply chain management system or even a warehouse management system, and they implement it, and they'll pay $30 million for it. And then over the first 2 or 3 years, they'll pay over $100 million trying to make it work. So do you think the vendor will give you a discount on the sale as long as you retain them for a contract for a long period of time? Of course you will, because their retention and their development is much greater than the actual cost of the product itself, because you tie them to that system. And I was talking to this one company, and that they said, yeah, we're the same story. And after about a month, about a year, a year and a half, we scrapped it, went back to the old system, and we lost millions and tens of millions of dollars. So got to be careful out there. Okay, I think we've hit this enough. I think you guys are fun. We could talk about this forever. Hopefully this is helpful to people. But this concept here, I think understanding this is valuable and useful. And as a matter of fact, we'll use it in the next week. And this concept is used a lot in just looking at cost and changing and modifying your lot sizes and inventory policy within a supply chain, even with stochastic demand or lead time. And so it's very, very practical. Okay, the carrying cost determination, a commonly used expression for carrying cost is C sub C is I times C. Now this I is my variable. I picked I could have picked anything, but the C sub C and I, both of those are carrying cost. C sub C is a unit carrying cost to carry one item of inventory. I is a cost to carry $1 of inventory. They're both carrying cost. As a matter of fact, right now, I'll emphasize this over and over again. Be careful. Be careful looking at the variable names. Those variable names could change. Every company could have its own. What's important are the units, how it's used, and how it's interpreted. That defines the actual variable, not the variable name. So I could say I could say C sub C, and so in other words, this could be C sub B, this could be C sub C in some companies. So, or this could be H in some companies. I've seen all different things being used in companies, even textbooks, because there is no standard. And then C is a unit or item cost of one inventory item. So the idea is this. Let's suppose that your item costs $6. Again, just like I said before, a $6 bottle. Who said that, Craig? What was it, $50? Anyway, a $6 bottle. So that bottle's $6. Okay, suppose it costs me $1.20 to carry that item over a year. And look at your whole carrying cost, look at your average inventory. You take your inventory, divide how many items, how much cost you had, divide by the items as cost per item. Okay, but then how much is that per dollar? Well, if C sub C is 120, if C is 6, what is I? Okay, well, it's 120 divided by 6. Okay, so if it's going to be 20 cents, it's going to be 20 cents per dollar. Because of each one of those, let me do it this way. If each one of those dollars there's $6 in that item. So if I have 0.2, there we go. 2, 4, 6, 8, 10, 12. This is equal to 1.2. Okay, so if the whole item is $1.20, and it's 20 cents for each of the dollars, then the whole item is $1.20. Maybe I kind of hit this. Maybe it's too much, but hopefully you can see what I'm trying to say. Why? Why do we do this? Where IC then equals C sub C. 20 cents times 6 is 120. Why? Because a lot of times the value of I, and also since that's true, the EOQ equation, the C sub C here of 120, we replace that with IC. Turns out to be 0.2 times 6. You get the same answer. Why? Because the value of this I, carrying cost per dollar, can be determined from financial information. I is the total carrying cost per year divided by the average inventory. Well, in your statements, in accounting, you've seen these financial statements. So what they'll do is here's a total inventory carrying cost. Here's how much it costs to carry your inventory. Well, how much inventory did you have? Oh, you had this much inventory. But a lot of times that inventory is expressed in dollars, not items. And so if you take the cost of your inventory by your inventory in dollars, that's cost per dollar. If that's cost per dollar, then you say, oh, okay, well, to get the cost per item, I have to know how many dollars are in the item. So here, I take, if it's $6 in the item, here's my EOQ of 1040, I get 31.12, and I get my carrying cost of 20 cents. So my inventory cost is $6.24. And the Q over 2 is 31.20. So if I take these, I get 20 cents. So you just take this and you get to 20 cents per dollar from the example we had above. Because my EOQ is 1040. If my EOQ is 1040 times 6 is how many dollars I have, divided by 2 is how many my average inventory in dollars. So that's my average inventory in dollars. My inventory cost then, suppose it was $6.24, which was above. Well, the actual total inventory carrying cost divided by my average inventory in dollars is 20 cents per dollar. And so a very common way to express carrying cost per dollar. As a matter of fact, usually how it's expressed in your financial statements. Okay. Then I have an exercise set just to have fun when you're watching TV and watching whatever you're watching. So here's I give you the numbers up here for 4 different problems, A, B, C, D, C, D. Then down here, I give the answers just to convince yourself that you can get them. Now down here, the basic EO, now we come to quantity discounts. This is the last thing we're doing tonight. Okay, here's the setup. Suppose we have an inventory item that's $125. Suppose this is our desk table. I'm on a desk. This desk cost $125 from the supplier. Well, suppose the business school is going to renovate, and that we renovated a few years ago. Actually, we moved and we renovated. And we're still renovating. And now that nobody's going there. But anyway, and so we called up the supplier and says, we want to buy a table, a desk table. Oh, okay, well, it's $125. Okay, fine. Well, we are renovating the business school. We're going to buy a lot of them. And they go, oh, well, how many floors? 6 floors. Okay, well, if you buy between 50 and 99 tables, all at one order, one purchase order, we will give you a 2% discount on the price and only sell each one of those to you for $122.50. So you get a 2% discount on the item cost, on the acquisition cost. And so you go, oh, okay, well, that's a pretty good deal. Well, the business school is being renovated, but there's other departments over on campus. They're being renovated. Maybe I can call them up and, hey, you want to go together? We use the same tables. Maybe we can go together and have a good quantity discount. They go, well, if you have a lot of different buildings that are being renovated, if you buy 100 or more tables, I'll give you a 5% discount and sell you each table for $118.75. A very, very common, exactly, the Jake Jebs conference room there on the first floor. So a very, very common thing in business is that if you're going to buy more, they'll give you a discount on the price point, the item cost to you, the price to them, because they'll earn the money back on margin and volume. Okay? So you can either make $10 on one item, or you make $5 on 100 items, and you're going to make a lot more money. Okay. So remember before, just like Omar said, we're going to have the carrying cost, the Q. Let's back up here. For EOQ, up here, so EOQ here, the Q will vary according to the carrying cost. Q will vary the ordering cost, but the acquisition cost is independent of Q. So it doesn't matter what this cost is for this type of model. But look at quantity. Now this C here is your item cost, your acquisition cost. Okay, now let's look at this down here. Now, the item cost, if the item cost does change when your Q changes. So now the ordering cost will change relative to Q, the carrying cost will change relative to Q, and now the item cost changes relative to Q. Because if you order more, you have a discounted on the cost, item cost. So this cost changes with a higher lot size Q. So the C then will change, the total acquisition cost or the total item cost will change. So now we're deviating. It's the same concept of minimum cost, but now we have three variables, and this is not continuous, this is tiered. So therefore we have a disjoint continuous. So now we have a different technique. It's a four-step procedure right here. Here are the 4 steps. Here's a table that are actually doing the 4 steps. Here's the answer. And down here's all the calculations going into the 4 steps. Okay, so let's do it. First, we have some variables in here. The demand is 200 items a year. I'm picking really simple numbers so it's easy to see what's happening. 200 items a year. The unit ordering cost is $50 per order. The carrying cost now. Notice I'm saying C sub C, I, whatever you call it, it's 40 cents per dollar per year. So it is a carrying cost. So I could call this C sub C, I could call it. So back when I made these notes, I thought, I'm going to put both of these in here just to emphasize that the variable doesn't matter, the actual units matter. Because this is carrying cost per dollar per year. Okay, let's go through this real quick. You have everything here, and there's a video too. As a matter of fact, if I bring up, let's see here, go back to home. Hello, come here. Go to my website, come to operations management. So it's not hard to get to. Inventory, quantity discount, video 4. I have a whole video on this. I even have an Excel spreadsheet on this. So boom, those two things right there. And also the memo is going to be based on this. The memo is based on this. Okay, whoops, don't need that anymore. Let's go through it. Let me show you how it works. First of all, step 1, calculate what I call initial Q for each category. Let's come down to the calculations, and here they are. I'm using the EOQ equation to get the initial Q. So even though it's an EOQ, I'm not calling it EOQ. I'm calling it just Q because it's an initial Q. Well, for each category, the 2's the same, the D's, the demand's the same, the ordering cost is the same, the carrying cost per dollar of 40 cents is the same. But now each category, the item cost, the acquisition cost is different. 125, 122.50, 118.75, those are the discounted costs. As a matter of fact, I took these 3 columns right here and I copied them down here just for reference. Okay, so I'm taking 125, 122.50, and 118. I'm calculating the Q, and I have these 3 initial Qs. I'm putting them here under step 1. I'm calling that my initial Q. Step 1. Step 2. From the initial Q, Determine what is called a feasible queue. Well, down here, if the initial queue is in the range, select the initial queue as a feasible queue. Otherwise, select the value in the range closest to the initial queue as a feasible queue. What that means is this. Category 1. Notice the initial queue is 20. 20 is in this feasible range. 20 is between 0 and 49. So it's in the feasible range. Since it's in that range, if I order 20, they'll charge me 125. So therefore, 20 then becomes my feasible queue because it's in the feasible range. Category 2. 20.2 is not in this range. 20.2 is below 50. So in order to have this 2% discount to see if it's going to help me, in order to purchase all my tables at $122.50, if I order 20.2, they'd charge me $125. In order for me to actually experience or have the 2% discount, I need a number in this feasible range. Which one do I pick? The one in this range closest to the initial queue. Well, 20.2 is below 50, so the value in this range closer to 20.2 is 50. 50 then becomes my feasible queue. Same thing here, 20.51 is below 100, so 100 becomes my feasible queue. So that's step 2. Now, step 3. Step 3 simply says calculate the total cost for each category. Well, if I calculate the total cost down here, I do that down in step 3, it's going to be the carrying cost, ordering cost, acquisition cost. Okay? Coming through here, it's going to be I times C times Q over 2, C sub O times D over Q, D times C. Okay, well notice what I'm going to be using is the feasible queue. And let me come up here and let me bold this and go bam. If I order this feasible queue, and let me shade this in just a little bit. If I order this feasible queue, which is in the range, that means I will have the discount, and then I will order it at this item cost. Bingo. Click, click. And there we go. See? So what's my C? It's going to be these. What's my Q? It's going to be these. So I want my total cost here dependent using these Qs and these Cs. And that's what I'm doing down here in the third category. So notice here's my C, the discounted cost, 125, 150, 118. Here's my feasible Qs, 20, 50, 100. There's my Qs again, 20, 50, 100. Here's my C, 122, 50, 125, 120, 50, 118. I do the calculations and I get the 3 costs. I bring the 3 costs back up here, and step 4 simply says which one of these is the minimum. The minimum is going to be this one right here. So now its EOQ is 50 with a total cost of $25,925, and that's basically how this stuff works. Okay, that's the mechanics. And again, the video goes through it slower, and I present it. But this next page, again, the graph to show how it works. Let me show what I'm doing here. I'm taking each of these categories, let me see here. Okay, my bit rate keeps lowering. If you can hear me, if you're still on board, could just click on me. Just click say, I hear you. Okay, just make sure my bit rate, it's going to come back, but may not be live. It'll come back when I record it. I mean, when I post the recording. because I'm being recorded, but this, I'm being transmitted and being recorded at the same time. Anyway, okay, quantity discounts. Okay, what I'm doing here, I'm taking this category. Okay, category 1 has 125 in it, right? Category 2 has a 122.50. Good. Category 3 has a 118.75. So this first equation here for category 1, it's over here, but I'm changing Q. I'm changing Q 10 to 150. Very good. That's good to know. You hear me, because they keep telling me the bit rate keeps coming up and down. Well, maybe the bit rate changes. There may be some delay or latency, but at least you're hearing me. And I'm getting your texts, your chat room. So I'm making 10 from 10 to 150. I'm plotting it. And this TC1, there's my category 1. See this line right here? That line there is my cost, is my total cost function right there. But category 1 is only applied from 0 to 49. So 0 to 49 here, that's the bold, that's the dark. It only is operative right there. Now category 2, the same thing here. Each one of these is this equation for Q. Let me move this out of the way. For Q 10 to 150, I calculate it. Well, TQ then, total cost for category 2 is between 50 and 100. So notice I even bolded that there. See? So this right here is 10 to 50. I could bold this. Probably should have. Okay. So this is going to be this right here. 50 to 100 is going to be the category 2. And category 3 is 100 or more. So that's what I'm doing. I'm plotting this here. So once I've done that, let me bring this up here. Once I've done that, then you can see, oh, my cost curve is disjoint. It goes to here, jumps down to here, jumps down to here. And so where's the minimum cost? The minimum cost of all of these is going to be right here. That minimum is 50 for the 25,900, whatever it was. So graphically, that's what's happening. And the reason I show you this is the kind of thing we'll do for the memo, but that's weeks later. But the idea is this. This shows the power of quantity discounts. That's why I'm covering it. Quantity discounts is becoming more and more popular simply because on the internet, when you order things online, like go online. Why? Because they have control of these feasible regions. They have control of the discounts. They have control of the item cost. Years ago, before the internet, people would publish a pricing catalog, a cost catalog, a pricing catalog. And so whatever prices were in that catalog, they'd price it once a quarter. Then whether you wanted to, it was a binding contract, essentially. So that catalog was binding. You say, oh, I want to raise the price on you. You can't. You can take it to court of law and say, you quoted this, and you have to honor your quote. And it can force you to pay it in these manuals. And so today, go online. Why? Because online, they can change this manual dynamically. And they do. It's very easy to change dynamically depending on a lot of factors. Okay, here's some examples. Let me see if I can get this right. Okay, let's see here. Suppose you have a company and you have all of these items. Suppose you have specialized items. Let's say, I think the memo is going to be tires. Okay, you have all these tires, these specialty tires like for huge earth movers or big cats and things. Anyway, for a backhoe or something. So you have these huge tires, like 6 feet tall. And so they're expensive. Say, oh, I have all this inventory and I order it, but no, I'm making these tires and selling them to my customer, and I have control of this, okay? And so, I'm going to come out with, I have all this inventory to ship to my customer. I'm gonna be making a new product, and so I want this inventory to go down. So I want them to order more from me. I want their lot size to be larger. Now, I know they do EOQ, okay? And I know they do EOQ with this quantity discounts. I know what they do. So I don't want to change the price because the price is competitive. I'm the lowest price in the industry. I don't want to change the discounts because the discounts is why my customers stay with me. But let me change the order quantity boundaries. Let me see. I want them to order more, so I know instead of having 100 here being the boundary, let me drop that to 75. So it's 0 to 50, 50 to 75, 75 or more. So if this goes to here, this goes to 75, and this drops to here, where's EOQ? EOQ is going to be 75. Now, I'm selling 25 I'm selling it over at 2% discount, or a 5% discount, not 2%. So I'm losing money, but I'm getting rid of my inventory. I want to get rid of my inventory at 5% instead of 2%, because if not, I'll be eating it, because they're not going to buy it once I have this new product. Okay, I'm coming out with a new product here in the next production run. Okay, fine. So they do that, and sure enough, they buy more, and all of a sudden that inventory goes down. All right, and you priced it, you timed it great. The inventory went into almost nothing, to where you only throw away just a few tires. Okay, you don't have to waste hardly any money at all. That's good. Now I'm going to have new tires coming on board. Oh, wait a minute here. Wait a minute. Now I know that everyone orders according to this EOQ, but now I don't want everyone ordering a lot, because it takes me time to produce them. I want them to order smaller amounts so I can satisfy all my customers, because if I can't satisfy them, they may go to my competitor. So I want their EOQ to be small. So again, I don't want to change my item cost or my discount. I want to change the order quantity. Let's see, how can I do that? Well, let me move this back up to 100, and let me move this 50 here. Yeah, I'll move the 50 up to 75. So now this goes from 0 to 75, 75 to 100, 100 or more. So the category 1 goes from here all the way up to 75. Then this comes down to here, and here. So now my EOQ, they're going to order 20 from me. Well, if all of my customers only ordered 20 instead of 75, I have enough to satisfy all of them until I get more inventory produced. Okay, and I'm good. And so this is a simple example that probably has never happened exactly like that. But that's exactly the kind of things you can do online when you have quantity discounts and selling these things online. Okay. So that's why I'm covering quantity discounts. And the memo will be this, as I said, will be something like this, and we'll be talking about something a little bit different about this with the memo and the homework. So the quiz is going to be the mechanics, the homework is going to be the applications, and the memo is going to be communication. I think that's the end. That's the end for category number 1. That's enough. A lot of stuff. Oh man, a lot of good questions. I really do like the questions, and I think it puts it in perspective. And you guys stuck with me here to 9 o'clock, 2.5 hours. That's pretty much what it should be, because we should be here 2.5 hours because you didn't take a break. It's hard to take a break when you're having so much fun. You know what? This stuff is so cool, and the questions make it even cooler. This is good. This is good. This has been good. So hopefully this helps, and hopefully you kind of understand why inventory is such a strategic element to any business when there's a lot of inventory. Okay, and that's why people try to reduce inventory, because it's a lot of times people mismanage it, or they don't have the ability to manage it well. But anyway, inventory is really important. Next week we're going to cover inventory number 2, and inventory number 2 is going to be stochastic. Okay, let me bring this back up. Next week I'm going to be covering stochastic. Essentially 3 models, but in those 3 models, I'll be covering how to work this, how to work probability into that, and then how that becomes, again, takeaways, things to recognize that are heuristic. I'll look at this technically, but then I go to some heuristic. Well, here, so if there are quantity discounts, we don't need C sub C2 equals C sub 1 anymore. Essentially, what you're doing, the concept is there, but the actual result is not literal. The concept is like when I said you want the interval closest to that. That's the same concept. You're trying to go to where they cross, but it's not where they cross. It's closest to that. Okay, so the concept is still there. It just isn't realized literally because of that third variable, which is not continuous. It's a non-continuous third variable, which introduces a disjoint, continuously disjoint function. Okay. Can you also go through the first 2 sections on homework 3? I'm struggling to find an answer that fits your solution set for 2, 3, and 5, 6. This is before you even get to the minimum cost section. Yes. Oh, this is before you get to the minimum cost. I tell you what, I think what I'm going to be doing, since you've asked this, Dana, if there's other people with the same questions, and there may be other people who are doing fine with that. So let me try something, and let's go back to Canvas, and I will answer that. But notice under, let's see, aggregate planning, notice we have a Q&A here. If you could post those questions to Q&A and see if someone has the first 2 answered, the level capacity, the chase demand. They go, oh, here's how you do it. And that's probably much faster and probably will answer your question better, because sometimes, as you can tell, I answer the question, but I answer it big. I answer this much when you just need this much. And sometimes a student can answer it much more directly. But if that doesn't work, this is Tuesday, Wednesday night, Thursday night, office hours, and I will visit this too here this week and answer it there. So post it here and see if that's going to work. That's one thing. The second thing is under the homework down here. Notice here I have a video 3 on how to solve the homework. Now, this Excel right here. Now this Excel template, I've covered with the homework, AP lecture. Okay, but this one is different. This one is for the homework. Well, so is this one, but this one's for the lecture. This one's for the homework. Well, let me show you what I mean. Let me just open this up. I think I covered this, when I went through, this talks about the level capacity, chase demand, mixed, and minimum cost. It's how to solve the things. Okay, so that's what that does. But this one is different. This one's for the homework. When you open this up, this is in my website, but I copied it here just to emphasize it. So here, let's see here. Yep, it does. it does do the different spreadsheets. I have level capacity, chase demand mixed. Okay, then I go into the LP solution just like I did before. But now I solve the thing, and then I go in for an LP2 where I add a minimum inventory of 200. Then I go in, I add FT requirement here of 110. And then I go down to even 103, and that will require overtime. It quit on me here. I should just open it up. My point is, maybe this isn't clear, but this Excel spreadsheet goes deeper. And this Excel spreadsheet is after. So this one talks about the minimum, question 4. This one talks about 5 through 6, or 5, 6, 7, 8, whatever they are. I don't remember what they are. And I'll have another video about this, maybe tomorrow or the next day. So then you can see how that works. And once you have it set up, and then you just put this in, put this in, put this in, you get the answers. So I'll put this in there probably tomorrow. But in other words, to answer your question, if you could post it here for the first, could you have the leveled in the chase, post it here. You have the optimal, which is going to be down here. Okay, video 3. Then you're going to have the modifications, which are here, and hopefully that will help us all go through it. I'm trying to think of the best way to do this for everybody to be helped across the board. And this is in this. This is in the this Excel spreadsheet right here. This is this one. Where's aggregate planning? Here it is. That's this spreadsheet right here. So it's on the on my website right here. Excel 2. This is Excel 1, Excel 2. These two right here. This one just ties into this third video. But this one is Excel from the lecture. This is Excel from the homework. I used the lecture examples, but the homework type questions. Okay. Well, hopefully this video will help, and this will help, and the Q&A will help. And if that doesn't help you, Dana, and you need more specific help, or just go ahead and come to office hours, and I'll do it, and I'll work through it with you, show you how to do it. Okay. But Dana, you're right. I mean, my experience is that when you're not getting the first ones, there's a lot of moving parts. Sometimes you have to go back, go step by step. It happens to everyone. It happens to me too. Is that sometimes there's just one number over here that you just don't see, and that's very easy to do. That's why once you get them all done, then you can start building on it. Okay. But the first two, the level and chase, are going to be important. Then the minimum cost is important. Then you need to modify it. Okay, I'm stalling here to see if anyone else has any more follow-up questions or comments or statements or anything before I leave. And some people may have tuned in late. I have office hours here Monday, Wednesday, Friday at 7, but also this Q&A for questions about the material. I'm going to try to use that more because then everyone can see these questions instead of just one-on-one. Because I have, because sometimes I answer them well, sometimes I answer them in too detail, and I'm hoping this will be better. Okay, it's been a while, so I think I'll sign off. I really hope this helps, and if you have any questions, you can see me. I'll every day or so I'll go into the Q&A to see if there's any questions, and Kat, is that Kat Kuistra? I enjoyed your video. I enjoyed your memo. It was very good. You did a very good job. You're a good communicator. What was I saying? Oh, yeah, I'll be visiting the Q&A quite often to make sure that all the questions are answered. Wednesday night at 7, Friday night at 7, office hours. If you have any questions, for me personally on a one-on-one kind of a thing. And sometimes if the Q&A doesn't work, well then you can ask me directly. And sometimes email doesn't always get to me. And sometimes when it does get to me, it's hard for me to understand what's being asked unless we can talk it out. And that's why the Q&A, talking to each other, and then the video with the Zoom. That's all I have for tonight. I really appreciate the questions. I think it's been a very good, helpful night to talk about inventory, the basics. And next week, we'll get into a little bit more application, a little deeper, some more interesting things, a little bit more practical things. And so I'll be watching for the videos. Instead of doing the homework in the live stream, I'll do the homework with videos. And then you can ask questions like for next Tuesday night. So that's all I have for tonight. Between now and the next time I see you, again, I want to tell everyone to be careful. Don't take anything for granted. Be safe out there. And be safe, be well, so you can keep on learning.